Moment of inertia for transverse section. Zarka, tell me, where did we end in last lecture? Zarka, are you there?
Yes. So we did a movement of inertia of a hollow circular section.
Okay, fine. Today we will see what will be a moment of inertia in a triangle. Fine. Let's say we have this triangle E, and here what we have to find out, we have to find out moment of inertia for this triangular section. We have to find it. What will inertia? Now what we will do? Let's say it has a width of B, it has height of H. This is the width of angular section, and H is the height of the triangle section. Now, what we actually do in triangle, or in any of figures, we consider elemental area, consider small strip uh, of a plane figure, and we see what will be the inertia of that particular strip, of that particular elemental area. Let's say here we have considered this elemental area, Q, and it has a thickness of dx. Okay? And that elemental area towards the top of the vertex is x. This is x, and the total height triangular section is x. Okay. Now what we have element a strip PQ whose thickness is how much dx, and width is PQ. Now from geometry we can here see we can here we can have actually a big triangle and a smaller triangle. We have two triangles now, uh, like AP, and we have triangle AP and Q, and we have one more triangle which was the triangle which is AB. Okay, and we can see that how much PQ will be BC times X divided by H, and you know how much is BC. Okay, now we also have to find out the area of uh, that elemental area strip. How much will be that? A strip PQ area will be simply how much? PQ times dx. It will be PQ multiplied by dx is the thickness of that strip. Now PQ you have already got that. That comes out to be B multiplied by x divided by h into dx. This is what? This is your area of the strip PQ. Fine. And after this, what we are actually supposed to do, we are actually supposed to calculate the moment of inertia. We're actually supposed to calculate the moment of inertia. Let's say from base BC, reference line is BC. From base BC, okay, which is actually equal to, as you remember, it is equal to, when we have to calculate the moment of inertia about any axis, it is simply equal to area multiplied by distance. Okay, distance square. It is area multiplied by distance square. Now we have to find out what will be the area, right? Area of the elemental area, which is PQ. Now that will be simply equal to firstly area. What will be area into distance square. Now area is simply it will be total area will be the area of the strip firstly, right? It will be the area of the strip. How much is that? It is bx divided by h into dx, right? It is what we got from here, multiplied by what? The distance. How much is the distance? Distance from the base. Distance from the base, total height of the triangle is h, and then from the point PQ up till the point A, it is x. That means height will be simply h minus x raised to the power of 2, right? And we can write this as bx by h minus x square dx. This is your moment of inertia about the baseline BC. Now, what we have to calculate? We have to calculate the moment of inertia of the triangle, of the whole area. It was the elemental area, small strip of the area, PQ. Now, in order to find out the moment of inertia for a whole triangle, what we have to do? We simply have to integrate it within the limits, right? Within the limits. Limit should be such that which include the total area of the triangle. Okay. Now your moment of inertia mi for triangle ABC, it can be simply calculated within the limits height 0 to h, right? Limits will be 0 to h. That means moment of inertia about BC will be equal to integral of 0 to h, because total height is h. 0 will be at baseline BC, and at top it will be h. That means bx by h minus x raised to the power of 2 dx, which we can now we have to integrate it for the limits valuing x, right? Because x is from 0 to h. Therefore, we can b is not b will be out, h will be out, and it will be integral of 0 to h x times h minus x square. It will be h square plus x square minus 2hx multiplied by dx. Now integrated, it will be b by h integration of x. It will be now xh square plus x square cube, sorry, x cube minus twice hx square dx. Now that will be equal to b by h integral within the limits 0 to h. The x square h will be, it is x, it will be x square h square by 2 plus x cube will be x4 raised to, divided by 4. Then it will be minus twice h x cube by 3 within the limits 0 to h. And giving the values of the limits, which is 0 to h, it comes out as bh cube by 12. This is what moment of inertia about BC. This is your moment of inertia about BC. Now, what will be the moment of inertia uh, when I say I want to calculate the moment of inertia about an axis through its center of gravity, can anybody tell me what will be the moment of inertia about an axis which is through the center of gravity? Any idea? Now, this was moment of inertia IBC. This is at the base, right? This is at the base of the triangle. Now, I want to calculate what? Moment of inertia of whole triangle. Of course, now we are talking about whole triangle. What we need here is moment of inertia of a section about axis which is passing through center of gravity and which is parallel to x-axis. Now that will be which we have already done by the theorems, which is parallel axis theorem, in which it is mentioned this way: when we want to calculate the moment of inertia about any axis which is parallel to ixx, then that is actually equal to moment of inertia about the center of gravity plus area times square root of h square. Right. Now, when we have already calculated, here are ix axis what? Here, when we are talking about calculating the moment of inertia about the axis which is through the center of gravity, that means somewhere here, that will be somewhere here, center of gravity will be somewhere, let's say at this point, which you also know that for a triangle center of gravity will be somewhere at a height of what? H by 3, if you remember, from this point, and it will be 2h by 3 from this point. But where is that point coinciding? You don't know that, because triangle can have any angle on any of the side. So therefore, they can be a similar triangle, they cannot be similar triangle at the same time. Now, in order to calculate the moment of inertia about that axis, which is this axis, which we have to calculate actually, that will be equal to moment of inertia about the centroidal axis, that will be equal to ixx. Here ixx is actually bc minus ah square. IBC, because it is parallel to x-axis. It is the same axis in which we need to calculate the moment of inertia. So moment of inertia about the axis by G, it simply means that we are actually checking the moment of inertia about the centroidal axis, about the, mark that, about the centroidal axis of the triangular section A, B, and C. Right? Centroidal axis of A, B, and C. That is equal to IBC x-axis. How much is that? That is already given. BH cube by 12. Right? BH cube by 12 minus area of the triangle. How much will be the area of triangle? It will be BH by 2. And then it will be h square. What is h? Where will be the center of axis? At a point which is at a distance of h by 3. That means h by 3 raised to the power of 2. Therefore, yes, Sahil, आप कुछ कह रहे हो? Your IG will be equal to, if you calculate, if you give the values, Ig will be equal to BH cube by 36. This is your moment of inertia about an axis which is actually passing through the center of gravity. Okay. Now, if you want to find out the moment of inertia of the axis through its vertex, and which is also parallel to the vertexes, point is your uh, this point is your vertex. Now, if you want to calculate the moment of inertia from the top, then in that case your Ig will be, if you want to calculate the moment of inertia through its vertex, then it will be simply equal to how much? Ig, Ig is center of gravity, simple, plus AH square, okay, which comes out to be BH cube by 4, moment of inertia through its vertex. This was regarding the moment of inertia of a triangular section.
सर ए क्या है आपने?
साहिल, आर यू सेइंग समथिंग? आपकी आवाज बिल्कुल नहीं आ रही है.
सर ए कैसे आया बी एच?
BH cube by 4.
ए कैसे आया बी?
Are you talking about BH cube by 4?
नो सर बी एच बाई 2.
Sahil, I am not able to hear you.
Area of a triangle.
हाँ, अच्छा, is he talking about BH by 2?
Yes, sir. I could make that much out. I think he's talking about that.
B is the total width of the triangle and H is the total height of the triangle. Are you talking about this one? I guess he has some issue with the network. So rest others, are you able to figure it out? Why is BH 2 by 2? It is the area of triangle, huh? Zarka, is it clear?
Yes, sir.
Shall we move ahead?
Yes, sir.
Now this was regarding the moment of inertia of a triangle. Now we will do some problems for composite sections. Moment of inertia of composite sections. Composite sections include our I sections, T sections, wherein we can divide any figure into two different plane areas actually. we are dealing with areas right now. We are not dealing with volume, or we are not dealing with weight or anything else. We are dealing with volume. So we are actually calculating the moment of inertia of different areas, right? So in such cases, we actually have to deal with L section. We have to deal with T section, composite I section, and so on and so forth. Here what we do, we basically split it into different planes, whether that be triangular, rectangular, circular, and we try to find out a moment of inertia individually, right? And then about their respective center of gravities finally, and then we transfer those movement of inertias to the axes on which we basically are in need of getting the moment of inertia, wherein we also have by parallel axis theorem we can do that easily. For example, if we want to calculate the moment of inertia about any plane AB, whether we don't know which plane is there, that is actually equal to moment of inertia about the center of gravity plus area times h square. We know this also by parallel axis theorem. And then finally what we have to do, we calculate the moment of area on such axes by just simply adding them up, or by the algebraic sum of the moment of areas. We add them up, right? Initially what we do, we divide it into different areas, and we try to calculate the moment of inertia of individual sections. And then finally, with the help of the parallel axis theorem, we try to calculate the moment of inertia about that particular axis, for which we have this formula. And finally, we add up all the triangular moment of inertia so that we can get the actual moment of inertia, which we will be able to properly understand by an example. Let's say we will start with an example. Example of an T section. Let's say we have this T section. Uh, it is 50 wide, and then it is 150 is the height of 50 is here, and then this is again 150. This is your what? This is our flange, and this is our web. Okay. Now what we need to calculate, we have to calculate the moment of inertia, right, of this section about x-axis as well as y-axis through the center of gravity of the section, right? We have to find out what moment of inertia about x-axis, y-axis through center of gravity, through the center of gravity of section. This is what we are in need of. We need moment of inertia about x-axis, y-axis through the center of gravity. Firstly, what we do, here we have two sections. We will divide it into two different rectangular sections, right? Let's say this is our section 1 and this is our section 2. Okay, and we will firstly try to find out center of gravity of two different sections, which we can easily do by the method of geometry, right? As we can also see that this flange is actually symmetrical, right? It is symmetrical in y-axis. In either of the direction of y-axis, it is symmetrical, but it is not symmetrical on x-axis. Simple. It is symmetrical on x-axis. Therefore, we can say the center of gravity will lie on this axis actually. But at which point on the y-axis it is, we need to calculate that. So what we do, we will actually split the whole section into two rectangles, rectangle 1 and rectangle 2. And we will say the reference line is the bottom of rectangle 2. This is our RF, RL, reference line. So firstly, in order to calculate the center of gravity, what we need rectangle 1 area, and that area is A1 will be equal to how much? It is 150 cross 50. That will be equal to 7,500 mm square, right? And what will be the center of gravity y1? Simply at the center of 50. That means from, if it is from the reference line bottom, from reference line bottom, it will be simply firstly you have a height of 150 and then plus 50 by 2. That means it is here at center. But from which line? From this line. Our reference line is the bottom of the rectangle 2. This will be equal to 150 plus 25, 175 mm. Right? This is for rectangle 1. And then rectangle 2. This is rectangle 1 and this is rectangle 2. Again, area 1 will be equal to 150 cross 50. That is equal to 7,500 mm square. And then we have y1. y1 is the center of gravity. It will be from the reference line, which is 150 divided by 2. How much is that? 75. That will be 75 mm. Okay, this is with regard to each of the rectangle. That is rectangle 1 and rectangle 2. Now what we want to know is the center of gravity. Okay. From where? From the bottom. Center of gravity, the distance between the center of gravity of the section and the bottom of the web. This is now your web, right? And that will be calculated simply by y bar, which is actually, which can be calculated by a1 y1 plus a2 y2 divided by a1 plus a2. That will be equal to a1 is 7500 cross what is y1, 175 plus again 7500 multiplied by 75 divided by 75 plus 75 is 15. 15,000. That comes out to be okay. Zarka, tell me how much is the value of y1?
Just a second, I have to calculate it first.
Zarka, how much is it?
121.
Calculate it quickly. Anyone else who knows?
25.
Who has calculated it already?
1 to 1.
100 and huh?
1 to 5.
Muntaha, is it 1 to 1? Sahil, what is it? I couldn't hear it. How much is
1
it?
to 5. 5.
1 to 5. Sahil, are you saying 1 to 5?
Yes, sir.
125 मुझे भी आया.
Okay, 125 mm. So this is your distance of centroid of gravity and the bottom of the web, right? Now, what are we in need of? We calculated moment of inertia. We need moment of inertia about both the axes, that is about x-axis, about y-axis. But here we have two different sections, right? We will try to find out the moment of inertia for first section, and then we will try to find out the moment of inertia of second section about the x-axis. Now, okay, moment of inertia about x-axis. As we have already calculated for any rectangular section, the moment of inertia about the center of gravity. About the center of gravity. Can anybody tell me what is moment of inertia of rectangular section? About for an axis passing through the center of gravity and parallel to x-axis. Does anybody remember that? IG for rectangular section. Here, this is a rectangular section. If we want to calculate the moment of inertia about the axis through its center of gravity, if this is the center of gravity somewhere here, which is parallel to x-axis, right? This is our x-axis, and this is parallel to moment of inertia through the center of gravity. Then in that case, the moment of inertia, if you remember, is we calculated it earlier, BdQ by 12. Remember that? Does anybody remember that? Muntaha, did you remember that we had already
Yes.
calculated it?
Sir.
Okay, fine. Which is actually here in this case, it is equal to how much is B? It is 150. And then we have D, how much was depth? It was 50 cube divided by 12. And calculating that gives me the value of 1.56 into 10 raised to the power of 6 mm4. Okay. Now I want to know what is the distance between the center of gravity and x-axis. Center of gravity, how much was it? Can anybody tell me? Now what I want a distance between, I want distance between center of gravity, CG, of rectangle 1 and x-axis. Now, where is that x-axis? That will be simply where? It will be at the center, at y1, right? Y bar, sorry. And our actual y1 was how much? Our y1 was y1 minus y bar will give us the center of CG of the rectangle and x-axis of that particular rectangle, right? Which is how much? How much is y1? It came out to be 175 minus, and how much is y bar? It is 125. That comes out to be 50 mm. Okay, this is our distance between CG of rectangle 1 and x-axis. Therefore, now we can calculate the moment of inertia of rectangle 1 about x-axis. About x-axis, which is equal to I G1 plus A1 H1 square. Let's say this has a name of H1. Okay, and IG1 is how much now? Which we have already calculated. Let's say this is our IG1. Let's name this as IG1, the moment of inertia about the centroidal axis. That is 1.5 6 into 10 raised to the power of 6 plus A1. A1 was 7500, right? Yes, it was 7500 into H1. H1 is 50 square. That is 20 into 20, sorry, 20.3 into 10 raised to the power of 6 mm4. Okay, this is moment of inertia of rectangle 1, right, about x-axis. Similarly, when we have to calculate the moment of inertia about moment of inertia for a rectangle 2 about axis through center of gravity and parallel to x-axis. That is again IG2. IG2. IG2 will be simply again for rectangle, it is B d cube by 12. Yeah, B d cube. Here for rectangle 2, B is how much? B is 50 and depth is 150 raised to the power of 3 divided by 12. That is 14.06 into 10 raised to the power of 6 mm 4. Now this is what this is your IG 2. Now and now we also have to calculate distance between what? Distance between the center of gravity of the rectangle 2 and x-axis. distance between center of gravity of rectangle 2 and x-axis. Okay. Now that will be your h2. Now h2 will be simply equal to y1. How much was y1? It is now 125 from minus 75. Okay, therefore, when we have to calculate the moment of inertia, mi moment of inertia of rectangle 2, that will be again equal to ig2 plus a2 h2 square, that is equal to ig2 is how much? This comes out to be 50 again, and ig2 is 14.06 into 10 raised to the power of 6 plus 75 area 100 multiplied by 50 square, that comes out to be 32.81 into 10 raised to the power of 6 mm4. Okay, now moment of inertia mi for whole section. For whole section about x-axis, we just have to add up about x-axis, that will be equal to ixx will be equal to 20.3 into 10 raised to the power of 6 plus 32.8 into 10 raised to the power of 6, that is equal to 53.125 into 10 raised to the power of 6 mm4. This is your answer when we are calculating the moment of inertia about y-axis. Now, when we have to calculate what moment of inertia about y-axis, when we are calculating the moment of inertia about y-axis, we know that the mi of triangle 1 about y-axis is about y-axis. Now I am talking about y-axis. Moment of inertia of rectangle, then you can leave. Now we want to calculate the moment of inertia about y-axis. As you already know that this section T section was symmetrical about y-axis, right? So you need not to calculate the center of gravity and then use the this parallel axis theorem in case when you are calculating the moment of inertia about y-axis. So simply you can calculate the moment of inertia of rectangle 1 as bdq by 12, which is for rectangle 1, b is your 50 and your d is 150, q by 12, which comes out to be 14.06 into 10 raised to the power of 6. Right. mm4, and then for rectangle 2, your moment of inertia I is bd cube by 2, again 12, sorry, bd cube by 12, but here b is your 150 and d is your 50 cube by 12. That comes out to be 1.56 into 10 raised to the power of 6 mm4. Now total moment of inertia will be summation of these two. That comes out to be how much? 14 and 1 is 15, 15 and 15. Okay, it will be 15.62, 15 point, sorry, 15.6 into 10 raised to the power of 6 mm4. This is your moment of inertia about y-axis, IYY. We simply deal with an individual plane figures. Here
Hello.
we needed to calculate the moment of inertia about y-axis as it was symmetrical about sorry, we need to calculate it about x-axis, and knowing that it is symmetrical about y-axis, so we just simply calculated the moment of inertia about y-axis by simply bd q by 12, which was the moment of inertia about the centroidal axis. And then before that we calculated the moment of inertia about x-axis, in which we used theorem of parallel axes, and we calculated the centroid, center of gravity, and then we calculated the moment of inertia about x-axis in both the cases, and then finally we added them up, and that gave us the moment of inertia about the whole section, that is t section about x-axis. I guess this will be all for today. We'll continue it tomorrow. I guess we have tomorrow. Yes, in the morning we have class, so we'll continue it in our next class. So Faizan, shall we end it for today's session? So sorry, Sahil, shall we end up today's session? Have you noticed or are you done with your attendance? I'm not able to. I guess there is some issue with Zarka. Are you able to hear me? Are you there?
Audible.
Zarka, are you there?
Yes, sir. Am I audible?
See who are present and yes, now you're
Sir,
audible. Sahil and Zarka, you both can.
So Sahil is here.
Sahil, you wanted to say something.
sir, can you hear me?
Now it is okay.
Okay, sir. सर हमने वाई वाई क्यों नहीं किया कुछ भी? Sir, we just winded it up.
Huh?
About y axis क्यों नहीं हमने किया? We just winded it up ना?
वाई एक्सिस तो किया ना, दूसरे सेशन में नहीं आपने देखा?
जी सर, लेकिन सर आपको वहां पे bd क्यूब लेना था या db क्यूब लेना था? About y तो db क्यूब होता है ना सर?
हाँ, क्या कह रहे हो?
सर हमें db क्यूब लेना था या bd क्यूब?
No, that will depend upon it will be different in both the cases, because it was rectangle in this for a flange your b is width, that comes out to be the 150, and d is depth, that is 50. Whereas in the web portion your b is width, that is 50, and your depth is how much? Depth is 150. It changes, it depends upon the orientation or the dimensions of the rectangle. You didn't
Okay sir.
you
Yes sir, understood.
you didn't हाँ
सर
समझ
आई
आया?
गॉट योर पॉइंट। हाँ हाँ मुझे आया समझ आप क्या बोल रहे हैं।
ओके ठीक है।
इसमें फिर
चलिए
लेकिन
कोई बात
उल्टा
नहीं
आएगा ना सर, जो पहले हमें रेक्टेंगल 1 के लिए आया था इसमें वो 2 के लिए आएगा ना।
क्या मुझे समझ रहे हैं?
कुछ नहीं सर।
बताओ बताओ इफ यू हैव एनी इशू।
सर इसमें उल्टा आ जाएगा ना, जो हमें इससे पहले एक्स एक्स के केस में आया था, तो इसमें उसका उल्टा हो जाएगा ना।
हाँ इसमें उल्टा हो जाएगा बिल्कुल।
ओके सर, हाँ हाँ ओके।
इसमें इसमें अब आप देख रहे हो ना वाई एक्सिस से, अब
हाँ
ये
जी सर।
चेंज हो जाएगा। पहले आप कहाँ से देख रहे थे? एक्स एक्सिस से।
सर वी हैड
ठीक है,
टू चेंज
आपको
ना
ये देखना
फॉर्मूला
है कि
आल्सो,
आपका
हमें
रेफरेंस एक्सिस ना,
हमें
फॉर्मूला यू
डीबी
डोंट
क्यूब
हैव टू चेंज
निकालना
फॉर्मूला, फॉर्मूला विल बी सेम। ना ना
है।
ना,
हाँ सर नाउ
फॉर्मूला विल
अंडरस्टूड
बी
कि
सेम,
वो चेंज हो
बट
जाता है, बी
आपको
और डी स्विच हो जाते हैं।
किस एक्सिस से आप देख रहे हो, हाँ आप किस एक्सिस से देख रहे हो वो सिर्फ आपको ये ध्यान में रखना है। आप एक्स एक्सिस से देख रहे हो या आप वाई एक्सिस से देख रहे हो।
ओके
ठीक है
सर,
ना?
हाँ आ गया समझ में, हाँ जी सर।
चलिए ओके।